All right, welcome back to Miss Lasley's math videos. I don't know, that sounded better than math with Miss Lasley. I don't know. I probably should get an intro, but maybe not, right? The school year's almost over. Okay, so today we are on day 4. So we're not going to do any more proofs. All right, but what we are going to be doing is we're going to start solving. Now, the reason why we kind of worked with those proofs is because it's going to help us when we get to this solving piece. We're going to see in our problems we're going to end up basically simplifying before we can actually solve the problem, right? It would be very difficult to solve things that had both like sines and cosecants and tangents and all that kind of stuff mixed into the equation. So when we see that, we're going to simplify and then we'll be able to do the solving piece. So that's kind of why we do the proof part first. It's not just to make your lives hard and make you do proofs. It's because when we're solving for x with trig equations, we have to do that simplifying piece before we can actually get to the solving part of it. So today you're not really going to see too many of those trig identities, but as we start working through solving, you'll see more and more of them pop up, like your Pythagorean identities. You're going to see the reciprocal ones. So just kind of keep your eye open. So we are introducing how to solve trigonometric equations. We're going to discuss our goal for solving. We're going to look at some things that come up a lot that you don't want to do, and then we're going to do a couple practice problems. All right, here we go. So first off, our goal. So we are solving an equation. All right, so our goal is to find all of the x values that satisfy your problem on the given interval. All right, so find all x values. Now, you don't always have x as your variable. Sometimes you have theta or beta or alpha or whatever it is in the moment. All right. So it could be theta, could be alpha, could be beta. Doesn't matter. All right. So when I say find all x values, I mean find all of the unknowns, right? Values that satisfy the given equation over some interval. Now, when we do normal solving, we don't have to worry about that over some interval piece, right? So that part's kind of strange. That's not usually in normal solving problems because you don't have an interval, right? You just find your one value that makes x equal to whatever and you're done. Well, that's not how it works with trig. All right, so because trig functions have unlimited answers, right? They do go in both directions, in the positive x direction and the negative x direction forever. You need to find all of the answers that make it true within the given interval. All right, so if you take a peek down at example 1, it says solve each equation for theta in, so that weird e, that's the symbol for in mathematics. So it's like in the interval of 0 to 360. All right, so we're looking for all of the solutions from 0 to 360. All right, sometimes you might just have one solution. Sometimes you might have 3 or 4 solutions. It just depends on the problem that you're working with. All right, now, just want to kind of recap. When we did inverses, because we are going to be using inverses in these problems, all right, to solve our trig equations, when we did inverses, we talked about how different trig functions have that restricted domain, that those quadrants that you can only pull values from. Now, when we're doing these problems, that's not going to affect us because we're given the interval we want to work on. So I'm saying find all of the answers, even though some of them are like repeat values, right? Find all of the answers from 0 to 360. All right, there are certain solving equation or solving problems where it doesn't give you an interval. It just says like find the value, and it might be like find one instance that would solve the problem, and then you would use that those quadrants that we talked about for our different trig functions. So that's something that's not really going to come into play. Usually it would. But we did have to cut a lot of stuff out of this unit. So we're actually not going to get to the problems where you would need to remember which quadrants different trig functions have their values in. But I'll touch on that in the next class's notes a little bit more. But that piece kind of got cut out. So yeah, anyways, we want to find, our goal is to find all x values or theta or beta, whatever, values that satisfy the equation between, for these ones, 0 to 360. All right, and we might have multiple answers, and that's okay. Okay, now, things not to do. The most common things that people do are cancel out x values. All right, and I'm going to give you an example of what I mean. So this is like the main no-no. All right, and you guys do this with x also. So it's not just you're going to do it with your trig stuff. You do this when we're factoring normally. All right, and this is what I mean. So there was a problem on your very first like unit 0 test that looked something like this. It was like, oops, that's the highlighter. It was like, example. Oh, things not to do. Hold on. Let me just go back. Number 1, don't cancel out variables. All right, so that's the main rule here. Now I'm going to show you what I mean by it. So, example. All right, 36x squared, x to the 4th, not x squared, x to the 4th equals 25x squared. There we go. Okay, hold on. It's taking a slow time. There we go. All right, so we have 36x to the 4th equals 25x squared. Now, what a lot of you guys are very tempted to do is to simplify out the x's. So I see this happen all the time. You'll divide both sides by x squared. Then what you do is you cancel out the x squareds over here on the right-hand side, and you simplify x to the 4th over x squared to be 36x squared equals 25. You've just got rid of 2 solutions, all right? So we've talked about this when we did our polynomial unit. Something to the power of 4 has a total of 4 solutions. What you've just done is you got rid of 2 solutions to our problem, right? You just divided them out. So now I have a 36x squared equals 25, and I don't have any solutions, right? So you just got rid of 2 of them. This same thing happens all the time in the trig problems that we're also going to do. And they look something like this. All right. Let me pause so all the writing up. Okay, so this is what it looks like with trig. So that's what it looks like algebraically. Here's your one that's your trig problem that you do it with. So hold on, this is, oops, wrong. Don't do that, all right? And again, this is what it looks like with trig. So you would have something like sine theta equals sine theta times cosine theta. All right, so sine theta equals sine times cosine theta. What students do all the time is they will divide both sides by sine theta and simplify it out. All right, there it goes. So what I see happen all the time is divide both sides by sine, cross those off, and then this becomes 1 equals cosine theta. What you just did was you got rid of the sine theta solutions to the problem. You cannot do this. This is wrong. All right, so do not do that. You just deleted the sine theta answers to our problem. So in both scenarios, both the 36x to the 4th equals 25x squared and the trig scenario, sine theta equals sine times cosine, what you should be doing is moving everything to one side and using a greatest common factor, a GCF. All right, so for our trig one, what we want to do instead is subtract sine from both sides. So we want to subtract sine on both sides. Dun, dun. All right, sine minus sine makes 0. And then on the right-hand side, I now have sine theta times cosine theta minus sine theta. All right, now what I'm going to do is I see that both terms have a sine theta in them. So now I'm going to pull out a GCF, or greatest common factor, of sine. All right, hold on, the writing will catch up. There we go. So both terms have sine, so I can now rewrite this as 0 equals, pull the sine out front, parentheses, and what we're left with is cosine theta minus 1. All right, now for solving, all right, what we would now do is we would take each piece just like we normally would, equal them to 0, oops, not equals 1, equals 0, all right, and solve for theta. All right, so that's the technique that we want to use. So this is right. Okay, so don't delete things, don't divide by them to cancel out x's. All right, what you want to do is you want to move everything to one side and use a greatest common factor. All right, so that's use a GCF. Use a greatest common factor. That's the correct technique. Okay, so now we're going to move on to some solving problems. All right, so you guys can kind of see how they work. Now these ones are pretty simple, right? We're not really going to be using too many of our identities. I don't think we're going to use any of our trig identities for these ones. We're just going to use some solving, right? Because anytime you look at them, if you notice that you only have one trig function, then you're probably just going to just solve it like normal without having to use an identity. You're going to be using those identities when you end up with more than one trig like ratio being used. So if you have a problem where you have both a sine and a cosecant, or a tangent and a cosine, that's when you're going to be using those identities to try and get it to where you only maybe have one, or like we did in that problem right there where we have the sine on the outside and then cosine kind of by itself. That would be like a factoring technique. But ones like 1 and 2, we really aren't going to use too many identities. These ones are pretty straightforward. We're just going to solve them. So remember, ultimately solving, we're trying to get our variable by itself. And then we'll get into, finding all of the solutions that satisfy our equation. So with problem number 1, or just scroll. All right, I want to get, first off, tangent theta by itself. That's my first goal. So I want to get tangent theta to be all by itself. So the first thing I have to do is add 1 to both sides. So add 1, add 1. This one's like a hefty fraction one. That's probably why I picked it for an example. So now we have -3/2 times tangent of theta equals. Now I want to combine this, right? I don't want to do this problem without combining it. So I'm going to change 1 to have a common denominator with my fraction. So I'm going to change 1 to 2/2. And now I'm going to add. So I have -2 plus the square root of 3 plus 2 all over a denominator of 2. All right, I can even combine this, right? I see -2 and a +2, right? -2 plus 2. I'm going to add those, and that's going to make 0. So I now have -3/2 tangent theta equals just the square root of 3/2. All right, so I simplified. So now this is looking like a pretty doable problem. The next thing that I'm going to do is get rid of the -3/2 being multiplied to the tangent. So I'm going to multiply by the reciprocal. So I'm going to multiply both sides by -2/3, -2/3. All right, so I'm multiplying by the reciprocal. And so that's then going to become positive tangent theta equals, all right, now the 2's simplify out, and this leaves me with just -square root of 3/3. All right, so I have tangent theta equals negative square root of 3 over 3. All right, now the tangent is all by itself. There's no other numbers over on the side with tangent. The next thing I want to do is I'm going to use my inverse tangent to get theta by itself. So I'm going to take the inverse tangent of both sides. So inverse tangent of both sides. All right, inverse tangent and regular tangent are going to cancel each other out. So that leaves me with just theta over on the left-hand side. All right, so I have theta equals inverse tangent of negative square root of 3 over 3. All right, so this is an inverse problem. So this is now asking me for what angles, what values of theta do I have a tangent value of negative square root of 3 over 3? And because it tells me my interval is from 0 to 360, I need to find all instances on my unit circle from 0 to 360 that satisfy this problem right here. All right, so now, working through this one, I know that if it has a square root of 3 in it, it's either going to be my 30-degree angles or my 60-degree angles. And there was a trick that I told you guys in class that I kind of think of when I'm doing these ones to keep track of which one's which. If the square root of 3, if it's like a fraction like this, where it looks like it could have been 1 over the square root of 3, like if we were to kind of unrationalize the denominator, that means the square root of 3 was in the bottom of the fraction. Since this is tangent, tangent is y over x, I know that that means the square root of 3 had to have been with the x coordinate, which means this has to be my 30-degree angles. All right, so that's just the way I kind of work this out. So this has to be those 30-degree angles where your x value is root 3 over 2 and your y value is 1/2. That is how we get that root 3 over 3. Now, the next piece I have to think about is which angles is this going to be? So since it's a negative square root of 3 over 3, I'm looking for everywhere in all the quadrants where my tangent value is negative. All right, that's going to be in quadrant 2. We would have a negative tangent value, all right, and my 30-degree angle in quadrant 2 is 150 degrees. So one of my answers is 150 degrees. The next quadrant that I have a negative tangent value is quadrant 4. All right, so in quadrant 4, my 30-degree angle is 330 degrees. So my other solution is 330 degrees. So this, and now I can't go any further, right? Because I would be going over 360. So since I'm supposed to start with 0 and end at 360, because that's the interval that it gave me, these are my answers that I have for my problem. Now, just like every other problem that you do when you're solving, there's always a way to check your answers. All you have to do is plug 150 and 330 back into your equation, and it should give you the negative 2 plus root 3 over 2. All right, so if you wanted to check your answers, you 100% can. You just have to plug it back in, right? So to check, and I would recommend using a calculator for this. That way you don't have to do too much like by hand simplifying. So plug into your calculator -1 minus 3 over 2 tangent of 150. You should be in degrees because this is a degree, right? It tells us 0 to 360 degrees, so we're plugging in degrees, all right? And it should equal, right? So whatever decimal you get, so let's just do it together. Besides, I have to catch up to the writing hasn't shown up yet. So I'm going to go ahead and type in -1 minus 3/2 tangent of 150 and then hit enter. Oh, I'm in radian mode. Perfect. So now I'm going to try again. -1 minus 3/2 tangent of 150. Enter. All right, and this gives me -0.13397. All right, now what I'm going to do is I'm going to plug in that really beautiful fraction, -2 plus root 3 all over 2. And I should get that same decimal as my answer. So, oh, the writing is finally showing up. Excellent. All right, so now I'm just going to plug in -2 plus the square root of 3 divided by 2, hit enter, and that gives me -0.13397. So it works. All right, and you could do the same thing with 330. So you would just plug in 330 instead of 150 and see if you get that same decimal answer. And if you do, then that means you've done your problem right. All right, so you can still check your answers with these ones just like you would with a normal solving problem that you would do, right? You just need to make sure that your calculator is in the right mode. So since this one told us that our interval is 0 to 360 degrees, we should be in degree mode, right? And we should give degree answers. If you're going to see problems on your homework that say to do it from 0 to 2 pi, then your answers should be in radians because the interval that you're given is in radians. And then you would want to make sure if you're checking your answers that your calculator is in that radian mode. Okay, so doing this number 2, we have just one trig function. We just have secant. So what we're going to do is we're just going to try and get that secant by itself. All right, so here we go. I'm going to use blue, yeah, because I don't want to keep writing in that burgundy color. I'm bored with it. Okay, so just like normal solving, we're going to add 1 to both sides because we're trying to get secant by itself. So we add 1. That's going to give me 4 secant theta equals -4. All right. At this point, we can divide both sides by 4 because, again, we're trying to get secant by itself. All right. That leaves us with secant theta equals -1. All right. Now we can do inverse secant to get theta by itself. So we're going to do inverse secant of both sides. And that leaves us with theta equals inverse secant of -1. All right, so now we have to think about, okay, for what angles do I have a secant value of -1? So I'm looking at my unit circle. Remember, secant is 1 over your cosine or 1 over x on our unit circle. So I need that to simplify to -1. All right, the only angle that is going to have a secant value that simplifies to -1 is going to be 180 degrees. So theta equals 180 degrees. And that is the only time it happens between 0 and 360. So that would be our final answer. All right, that is it for today. I hope that was helpful for getting an idea of what's happening when we are doing these solving problems. If you have any questions on your homework, feel free to come by during office hours from 2 to 4. All right, bye guys.